या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रान्विता या वीणां वरदण्डमण्डितकरा.
Show that the motion of a simple pendulum is simple harmonic, and hence derive an expression or equation for its time period. What is seconds pendulum? So in order to answer this question, we have to consider a simple pendulum of length L, mass M, suspended from a rigid support as shown in the diagram here. The force acting on the bob or the weight mg can be resolved into two perpendicular components, mg cos theta and mg sin theta. One component mg cos theta balances the tension. The other component mg sin theta provides necessary restoring force. So restoring force is given by F is equal to minus mg sin theta, because this minus sign indicates the pendulum tends to move towards the mean position. But we know that F is equal to ma. From these two equations, ma is equal to minus mg sin theta. Therefore, on getting m cancelled both sides, a is equal to minus g sin theta. But when you observe this diagram, when theta is very small, sin theta becomes equal to theta. Therefore, a is equal to minus g into theta. It can also be observed that arc length is equal to radius into angle. Therefore, x is equal to r theta. Therefore, theta is equal to x by L. When you substitute this theta in the above equation, a is equal to minus g into x by L. This implies a is equal to minus g by L into x. If g by L is constant, a is directly proportional to minus x. Hence, it is proved that motion of the simple pendulum is SHM or simple harmonic motion. If omega is the angular velocity of the bob, then its acceleration a is equal to minus omega square x. But from the above two equations, minus omega square x is equal to minus g by L into x. On getting x and minus cancel both sides, omega square is equal to g by L. That implies omega is equal to under root g by L. But time period t is equal to 2 pi by omega. That is equal to 2 pi by root of g by L. That is equal to root 2 pi into root of L by g. Therefore, time period t is equal to 2 pi into root of L by g. What is a seconds pendulum? A pendulum whose time period is 2 seconds is called seconds pendulum. What are collisions? Explain the possible types of collisions. Develop the theory of one-dimensional elastic collision. Collision is a strong interaction between bodies in a very short interval of time, which involves exchange of their momentum. There are two types of collisions: elastic collision, inelastic collision. What is meant by elastic collision? It is the collision in which both momentum and kinetic energy are conserved. For example, collision between gas molecules. In gas molecules, both momentum and kinetic energy are conserved. They remain constant. Whereas in inelastic collision, it is a collision in which only momentum is conserved but not kinetic energy. For example, when a bullet is fired from a gun, the bullet hits the target. Here momentum is conserved, it remains constant, but kinetic energy is not conserved. If both momentum and kinetic energy remains constant during collision, it is called elastic collision. If only momentum is conserved but not kinetic energy is called inelastic collision. Now let's develop the theory of inelastic collision. Consider two bodies of masses m1 and m2 moving with initial velocities u1 and u2. But before collision, the bodies move with initial velocities u1 and u2. After collision, after interaction, the final velocities attained are v1 and v2. From the law of conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Therefore, m1 u1 minus m1 v1. m1 v1 is taken to left side, it becomes minus m2 v2 minus m2 u2. Therefore, I am taking m1 as a common factor. m1 into u1 minus v1 is equal to m2 into v2 minus u2. Let it be the equation 1. From the law of conservation of energy also, from the law of conservation of energy, 1 by 2 m1 u1 square plus 1 by 2 m2 u2 square is equal to of m1 v1 square plus of m2 v2 square. Therefore, I am taking 1 by 2 as common factor and getting cancelled both sides. m1 into u1 square minus v1 square. Rearranging this equation, m2 into v2 square minus u2 square. So therefore, let it be the equation 2. On dividing the equation 2 by 1, m1 into u1 square minus v1 square by m1 into u1 minus v1 is equal to m2 into v2 square minus u2 square by m2 into v2 minus u2. Now it can be observed that m1 into numerator is in the form of a plus b into a minus b. m1 into u1 plus v1 into u1 minus v1 by m1 into u1 minus v1 is equal to m2 into v2 plus u2 into v2 minus u2 by m2 into v2 minus u2. Therefore, corresponding terms get cancelled. Therefore, m1 cancel, v1 minus v1 cancel. u1 plus v1 is equal to u2 plus v2. u1 plus v1 is equal to u2 plus v2. Let it be equation 3. Therefore, u1 plus u1 is equal to u2 plus v2. Therefore, I am making v1 as subject. v1 is equal to v2 plus u2 minus u1. But according to conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So m1 u1 plus m2 u2 is equal to m1 into, instead of v1 we are taking v2 plus u2 minus u1 plus m2 v2. Therefore, m1 u1 plus m2 u2 is equal to, an expanding bracket, m1 into v2 plus m1 into u2 minus m1 into u1 plus m2 v2. Therefore, m1 u1 plus m1 u1, I am taking minus m1 u1 to left side, m1 u1 plus m1 u1 plus m2 u2 is equal to m1 v2 plus m1 u2 plus m2 v2. m1 u1 2m1 u1 plus m2 u2 minus m1 u2. m1 u2 is taken to left side, becomes minus m1 u2 is equal to m1 v1 plus m2 v2. Therefore, 2m1 u1 plus m2 minus m1 into u2 is equal to m1 v2 plus m2 v2. Therefore, 2m1 u1 plus m2 minus m1 into u2 is equal to v2 into m1 plus m2. v2 is common factor. Therefore, v2 is equal to 2m1 by m1 plus m2 into u1 plus m2 minus m1 by m1 plus m2 into u2. Explain reversible and irreversible process. Describe the working of a Carnot engine. Obtain an expression for the efficiency. So let's see what is reversible process. A process which can be retraced back in the opposite direction is called reversible process. Suppose fusion of ice, vaporization of water. Similarly, irreversible process is a process which cannot be retraced back in the opposite direction. Therefore, a reversible heat engine operating between two temperatures is called Carnot engine. Carnot engine undergoes a cycle of four processes called Carnot cycle. It consists of two isothermal and two adiabatic processes. Isothermal expansion of the gas from P1 V1 T1 to P2 V2 T1. Adiabatic expansion of the gas from P2 V2 T1 to P3 V3 T2. Isothermal compression of the gas from P3 V3 T2 to P4 V4 T2. Adiabatic compression of the gas from P4 V4 T2 to P1 V1 T1. When we plot a graph by taking volume on x-axis and absolute temperature on y-axis, heat absorbed by the gas from the reservoir at constant temperature T1 is nothing but the work done by the gas on the environment. Therefore, W1 is equal to Q1 is equal to nR T1 log E base V2 by V1. In the second step, adiabatic expansion of the gas from P2 V2 T1 to P3 V3 T2. Work done by the gas in the adiabatic process W2 is equal to nR by gamma minus 1 into T1 minus T2. W1 is the work done by the gas during the isothermal expansion. W2 is the work done by the gas in adiabatic expansion. Third step includes the work done on the gas by the environment is equal to heat Q2 released by the gas to the reservoir at constant temperature T2. W3 is equal to Q2 is equal to nR T2 log E base V3 by V4. During the step 4, adiabatic compression of the gas from P4 V4 T2 to P1 V1 T1, that is nothing but the work done on the gas in the adiabatic process W4 is equal to nR by gamma minus 1 into T1 minus T2. Therefore, total work done by the gas in one complete cycle, that is W is equal to W1 plus W2 minus W3 minus W4. And substituting all these quantities W1, W2, W3 and W4 in the equation, W is equal to W1 plus W2 minus W3 minus W4. nR T1 log E base V2 by V1 plus nR by gamma minus 1 into T1 minus T2 minus nR T2 log E base V3 by V4 minus nR by gamma minus 1 into T1 minus T2. Here we can observe that second term and third term get cancelled. Therefore, W is equal to nR T1 log E base V2 by V1 minus nR T2 log E base V3 by V4. The efficiency of the Carnot engine eta is given by W by Q1, that is equal to nR T1 log E base V2 by V1 minus nR T2 log E base V3 by V4 according to the last equation by nR T1 log E base V2 by V1. By taking nR as the common factor and get them cancelled, we get T1 log E base V2 by V1 minus T2 log E base V3 by V4 by T1 log E base V2 by V1. When we separate this fraction into two parts, T1 log E base V2 by V1 by T1 log E base V2 by V1 minus T2 log E base V3 by V4 by T1 log E base V2 by V1. That's equal to 1 minus T2 by T1 into log E base V3 by V4 by log E base V2 by V1. Therefore, efficiency eta is equal to 1 minus T2 by T1. Define momentum and impulse. State and explain law of conservation of momentum. Generally, momentum is defined as the product of mass and velocity. Since mass is measured in kilograms and velocity is measured in meters per second, kg meter per second is the unit of momentum. By the way, impulse, it is generally denoted by the letter J. Impulse is the average force acting on a body, average force acting on a body for a short interval of time. Let the short interval of time be denoted by delta t. Therefore, let us see the force, unit of force, newtons, and time, seconds. So, Newton second is the unit of impulse. By the way, state and explain law of conservation of momentum. According to the principle of conservation of momentum, let us consider two bodies A and B of masses m1 and m2. Here the initial velocity of the A be u1, here initial velocity of the m2 be u2. These two bodies collide each other for a short interval of time. Therefore, this is before collision. Here is during collision. Once they collide each other, they start moving with velocities v1 and v2. m1 attains the velocity v1 meters per second, m2 attains the velocity v2 meters per second. According to the principle of conservation of momentum, when there is no external force acting on the system, the total momentum remains constant. Therefore, according to Newton's third law, every action has an equal and opposite reaction. Action is equal to minus reaction. So now let us see what are action and reaction here. Rate of change of momentum of B is considered to be action. m2 v2 minus m2 u2 is the change in momentum. Therefore, rate of change of momentum is m2 v2 minus m2 u2 by t. Similarly, rate of change of momentum of A, this can be considered to be the reaction, m1 v1 minus m1 u1 by t. Therefore, m2 v2 minus m2 u2 by t is equal to minus of m1 v1 minus m1 u1 by t. Action is equal to minus reaction. On multiplying with t both sides, we will get m2 v2 minus m2 u2 is equal to minus m1 v1 minus to minus plus m1 u1. Therefore, once we rearrange this equation, m1 v1 is taken to left side, for example, m1 v1 plus m2 v2 is equal to, let us bring this minus m2 to right side. Therefore, m1 u1 plus, it will turn out to be plus m2 u2. Therefore, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is called the law of conservation of momentum. Total momentum remains constant. State and prove parallelogram law of vectors. According to parallelogram law of vectors, if two vectors are represented in magnitude and direction by the two adjacent sides of a parallelogram. Adjacent sides of a parallelogram. Then the resultant vector, and the resultant is represented by the diagonal passing through this point. passing through the point. This is the parallelogram law of vectors. If two vectors are represented in magnitude and direction by the two adjacent sides of a parallelogram, then the resultant is represented by the diagonal passing through the same point. Here let us consider the two vectors, vector A, there is another vector B. These two vectors are represented in magnitude and direction by the two adjacent sides of a parallelogram. Let us consider two vectors. Here, these two vectors make an angle theta. In order to construct a parallelogram, let us write a vector which is parallel and equal to the opposite vector, and draw one more vector which is opposite and parallel to this vector. So as a part of construction, let us extend this one to some other point. Here, join these two points so that it forms a right angle triangle here. So let us name this parallelogram AB. Here let it be the point C, for example. Here D, E. Therefore, according to parallelogram law of vectors, if two vectors are represented in magnitude and direction by the two adjacent sides of a parallelogram, side by side, then the resultant is represented by the diagonal passing through this point. Let the diagonal be represented by R. Therefore, here these two vectors make an angle theta. Therefore, here also these two sides are parallel sides and they are considered to be corresponding angles. That's why it is theta. Here, this component, it can be resolved into two components called horizontal component, here b cos theta, and the vertical component b sin theta. Therefore, now let us prove the parallelogram law of vectors. Here ACD, which can be observed to the right angle triangle, from triangle ACD, AD square is equal to AC square plus CD square. But AC can be written as AB plus BC. That means A plus B cos theta, A plus B cos theta square, CD B sin theta whole square. Therefore, it is in the form of A plus B whole square, A square plus B square cos square theta plus 2AB cos theta plus, on squaring this one, we will get B square sin square theta. Let us write these two terms side by side and bring out the common factor B square. A square plus B square into cos square theta plus sin square theta plus 2AB cos theta. Cos square theta plus sin square theta is nothing but 1. Therefore, AD is nothing but the resultant vector R. R is equal to A square plus B square plus R square is equal to A square plus B square plus 2AB cos theta. I want to find here resultant vector R. Therefore, under root R, on applying square root both sides, R is equal to S root A square plus B square plus 2AB cos theta. Therefore, if two vectors are represented in magnitude by the two adjacent sides of parallelogram, the resultant is represented by the diagonal passing through this point. Suppose we want to find the direction also, we have to consider the angle called tan alpha. Here in triangle ACD, we are considering tan alpha. Tan alpha is equal to opposite side by adjacent side. Opposite side is B sin theta by adjacent side a plus b cos theta. Therefore, when we want to find the direction of this resultant vector, tan alpha is equal to b sin theta by a plus b cos theta. Show that the trajectory of an object thrown at a certain angle with the horizontal is a parabola. Here let us see how does the situation take place. Actually, when an object is thrown at an angle other than 90 degrees with the horizontal, suppose an object is thrown with an angle theta other than 90 degrees with the horizontal, it moves in a parabolic path. That is what we have to prove here. If this object is thrown with certain angle theta with the horizontal, therefore it is called a trajectory. The path of the trajectory is a parabola. It is what we have to prove here. Here when the object is thrown with certain angle theta, since the object is moving in a plane, here the velocity vector can be resolved into two components, because here horizontal component of velocity acts, at the same time vertical component of velocity also acts in the downward direction. Therefore, ux can be taken as the horizontal component of velocity, uy is the vertical component of velocity at each and every point in the path of the trajectory. Therefore, horizontal component of velocity ux can be taken as u cos theta. It can be resolved into two perpendicular components, u cos theta. Vertical component of velocity uy, u sin theta. Therefore, we have to find out the horizontal distance traveled. Distance is equal to velocity into time, ux into t. So what is meant by ux here? U cos theta into t. Therefore, t is equal to x by u cos theta. X by u cos theta. Whereas the vertical distance travelled, s is equal to ut plus half ut square, y is equal to uy into t, because here we have to consider the acceleration due to gravity considered to be negative since the object is moving in upward direction. uy into t minus half gt square. What is the vertical component of velocity? U sin theta. Time factor t is equal to x by u cos theta. We are substituting this t in this place. Minus 1 by 2 into t can be replaced by again x by u cos theta whole square. Therefore, u sin theta into x by u cos theta minus 1 by 2 into g into t is replaced by x by u cos theta in these two situations. X by u cos theta whole square into, therefore, here u get cancelled. X into sin theta by cos theta can be written as tan theta minus 1 by 2 g into x square by u square cos square theta. So therefore y is equal to x tan theta minus, let us rearrange this equation in the form of 1 by 2 g by u square cos square theta into x square. Here let us consider this tan theta be a, g by 2 u square cos square theta be b. Now the equation is in the form of ax minus bx square. Therefore, this equation represents the path of the trajectory is a parabola. Here the minus sign indicates the parabola is in this direction. Therefore, y is equal to ax minus bx square. It represents a parabolic equation. Why is the lawn roller preferred pulling to pushing it? Let us picture the situation. Let it be the lawn roller Here, when you want to pull the lawn roller, this is the direction along which the force is applied. For example, what are the forces acting on this lawn roller here? Weight of the roller acting in the downward direction. Normal reaction, N is acting in the upward direction. Here this is the direction along which the force is applied with an angle. Therefore this force vector can be resolved into two components. F cos theta, horizontal component of force. F sin theta, vertical component of force. Therefore this is the situation of the lawn roller when it is pulled by certain amount of force F. Therefore N plus F sin theta is equal to W. N plus F sin theta is equal to W. Therefore N is equal to W minus F sin theta. But we know that force act is directly proportional to the normal reaction. Force applied is directly proportional to the normal reaction. F1 is proportional to N. F1 is equal to some mu into N. Therefore, mu into W minus F sin theta. This is the force to be applied when the lawn roller is pulled. Suppose the same lawn roller is pushed by the same amount of force F in this direction. Here, what are the forces acting on this lawn roller now? Weight of the roller W in the downward direction as usual, normal reaction in the upward direction. Here the force vector F can be resolved into F cos theta horizontal component, vertical component F sin theta. Therefore it can be noticed that the vertical component of force is added up W plus F sin theta, normal reaction N. Therefore N is equal to W plus F sin theta. Here when you want to find out the force F2 is directly proportional to normal reaction, F2 is equal to mu into N. Therefore F2 is equal to mu into W plus F sin theta. Therefore here when the lawn roller is pulled, F1 is equal to mu into W minus F sin theta. When the lawn roller is pushed, F2 is equal to mu into W plus F sin theta. Here which one is greater? Obviously F2 is greater than F1. Therefore the lawn roller is preferred pulling to pushing it. What is orbital velocity? There have an expression for it. The horizontal velocity required for an object to revolve around a planet is called orbital velocity. For example, let us consider an object of mass small m which is revolving around the planet of mass big M. It makes the radius r and h is the height of the center of mass joining the planet. Here what are the forces acting between the planet and the object? Here the centrifugal force is acting away from the center of the planet and gravitational force is acting between the object and the planet. Therefore centrifugal force mv 0 square by r plus height joining the center of mass to the planet r plus h. Mv square by r is the Formula for centrifugal force, Gmm by R plus H whole square. This is the formula of gravitational force. These two are balanced each other. Therefore, this object can be revolving around the planet. We are dividing both sides with small m and multiplying both sides with R plus H. You will get V0 square is equal to Gm by R plus H. But the radius of the earth R is very greater than H. Therefore, H can be neglected. So on taking square root here both sides, we will get V0 is equal to Gm by R plus H. Since H can be neglected, Gm by R. But we know that the relation between capital G and small g is Gm is equal to Gr square. Therefore, this Gm can be replaced by Gr square by R. Therefore, when R get cancelled, therefore V0 is equal to root Gr. This is the formula of orbital velocity whose value is approximately equal to 7.92. What is escape velocity? Obtain expression for it. The minimum velocity required for a body to escape the gravitational pull or influence of the earth or any planet is called escape velocity. The minimum velocity required for a body to escape the gravitational pull of the earth or any planet. Escape velocity. Let us consider a body of mass small m which is to be projected to escape the gravitational force of the planet, that is the mass of the planet be big M. Therefore, gravitational potential can be written as minus Gm by R. Gravitational potential energy is equal to gravitational potential into mass of the planet object minus Gm into m by R. Gravitational potential into mass of the object minus Gmm by R. This is called gravitational potential energy. So, in order to escape the body from the gravitational pull of the earth, here let the body be projected with the velocity of Ve. Therefore, kinetic energy of the body is equal to, here let us consider the suffix Ve. Half Ve square is equal to gravitational potential energy minus of Gmm by R, because these two are opposite and equal. Therefore, 1 by 2 mve square is equal to Gmm by R. And dividing both sides with small m, you will get Ve square by 2 is equal to Gm by R. Therefore, and taking cross multiplication, Ve square is equal to 2 Gm by R. Ve is equal to square root of 2 Gm by R. But we know that relation between small g and capital G, small g is equal to Gm by R square, Gm is equal to Gr square. Therefore, Ve is equal to 2 into small g R square by R. Once we remove this R numerator and denominator, escape velocity can be written as root of 2 Gr. Therefore, in other words, root 2 times root gr. So we know that root gr is the orbital velocity. Therefore, orbital escape velocity is generally equal to root 2 times the orbital velocity. Therefore, its value is approximately equal to 11 kilometers per second. 11.2 kilometers per second. State and prove law of conservation of energy for a freely falling body. What is meant by law of conservation of energy? According to it, it's not possible to create energy, at the same time it is not possible to destroy energy. In other words, energy can be neither created nor destroyed, but one form of energy can be converted into another. But the total energy remains constant. So once we apply the same form, the rule or law of conservation of energy for a freely falling body, here we have to prove that total energy remains constant. Total energy in the sense potential energy and kinetic energy. For example, let m be the mass of the object which is dropped to the ground at the point from the point A. C is the final point reached by the body. Let us consider one more intermediate point, let it be B. We have to prove that the law of conservation of energy is valid or it remains constant, total energy remains constant in all these three cases or 3 points A, B, C. So therefore, we know that at the point A, there is maximum potential energy associated with the body. At the point C, maximum kinetic energy is associated with the body. But whereas at the point B, both potential and kinetic energy also come into play. Therefore, let small m be the mass of the body which is dropped to the ground from the height h. Let x be the distance between or height from B to A. Therefore, now we are going to check the law of conservation of energy in all these three cases. At the point A, potential energy is maximum mgh, but whereas kinetic energy 1 by 2 m into velocity at this point, let it be va square, velocity of the object at this point va square. Since no initial velocity is there for this body, initial velocity is to be given for the body, for a free falling body, initial velocity is going to be 0, va or u is equal to 0, therefore kinetic energy is 0. So total energy is equal to mgh plus 0. So total energy is equal to mgh here. Whereas at the point B, this is the case at the point A. At the point B, the height of the body from the ground is h minus x. So let us write the potential energy at this point. mg into, what is the height of the body from C to B? When the body is at the point B, height is h minus x. Therefore, potential energy is equal to mgh minus mgx. But kinetic energy is equal to 1 by 2 mvb square. Therefore, 1 by 2 at the point B, displacement is x. Initial velocity may be considered to be 0. The final velocity is equal to Vb, let it be Vb. Therefore, a kinetic energy can be written as of 1 by 2 mvb square, but according to the formula v square minus u square is equal to 2gh, here v square can be written as vb square. Final velocity may be considered to be 0, therefore 2g, displacement is the distance travelled in x. Therefore, Vb square is equal to 2gx, and taking square root both sides, Vb is equal to root 2gx. Therefore, kinetic energy is equal to 1 by 2 m into 2gx. Here 2 divides 2 one time, therefore Ke is equal to mgx. But total energy is equal to Pe plus Ke. Pe is equal to mgh minus mgx plus mgx is kinetic energy. And minus mgx plus mgx cancelled. Total energy is equal to mgh. So in the second case also, total energy remains constant, that is mgh. Whereas at the point C, potential kinetic energy is maximum, the potential energy is almost zero because height of the object is zero. Therefore, kinetic energy is equal to 1 by 2 m vc square. Therefore, 1 by 2 m into vc is equal to root 2gh square. Therefore, 1 by 2 m into 2gh. If 2 gets cancelled, mgh. So kinetic energy at this point C is mgh. Therefore total energy is equal to, as usual, potential energy plus kinetic energy, 0 plus mgh. Here also total energy remains constant. Therefore at the point A, T is equal to mgh. At the point B, total energy T is equal to mgh. At the point C also, total energy is equal to mgh. Hence, law of conservation of energy is valid for freely falling body. Define strain energy and derive the equation for the same. Here let the length of the wire to be considered is L and the area of cross section be A, and F is the force applied on the wire. Therefore, what are the changes taking place? Average force is equal to F by 2. Work done W is equal to average force into elongation 1 by 2 Fe. Here we are multiplying and dividing with AL. Therefore 1 by 2 into stress into strain into volume of wire, that is equal to 1 by 2 into stress into strain. Strain energy per unit volume is 1 by 2 into stress into strain. Thanks for watching. All the best. Don't forget to subscribe Srinivasu S R Chaganti.